All right, here we go with the mole concept. For those of you that are having trouble with the mole concept, this is your tutorial. All right, the mole is a counting unit. It's a humongous number. 6.02 times 10 to the 23rd is the number. As you can see, it's right here. This is called Avogadro's number. The way it was derived is beyond what we need to know, at least in my opinion. But it is a humongous number set aside or used to count things that are very, very small, such as atoms, molecules, or ions. So before I get a little bit ahead of myself, how big is a mole? Here's a couple examples of how big a mole is. If you had a mole of pennies and gave one away, $1 million of it, $1 million of it a day to everyone in the world, it would take you more than 3,000 years to distribute all your money. That's an incredible amount. One of my favorite ones is down here. If you had an Avogadro's number of unpopped popcorn kernels and spread them across the United States of America, the country would be buried in over 9 miles of unpopped popcorn kernels. That's amazing. All right, so we're dealing with a very large number. Okay, now a mole is, and I went through over this in class. I just want to go over these two relationships. A mole is 6.02 times 10 to the 23rd particles. Now, it could be any particles you want to consider, but since this is a humongous number, we should probably talk about things that are very small: atoms, molecules, or ions. Okay, so this is an atom right here. This is a molecule right here, and this is an ion right here. So the answer to all three of these is 6.02 times 10 to the 23rd. Okay, so depending on what you're dealing with, you'll always have 6.02 times 10 to the 23rd particles as long as you're talking about 1 mole. All right, next. The second relationship. The first relationship is 1 mole is equal to 6.02 times 10 to the 23rd. Well, 1 mole is also equal to molar mass. And molar mass is found as it's the same thing as the mass number on the periodic table. So if you ever want to reference molar mass, you're going to look up what's on the periodic table. For example, 1 mole of carbon is 12.01 grams. Look up the molar mass, that's what it is. 1 mole of calcium ions is 40.1 grams per mole. Again, same thing as a molar mass. Chlorine is 35.5. Now, 2 moles of fluorine. So you double the molar mass. So the molar mass of fluorine, or excuse me, iron is 55.8, I think. Yes, 55.8. You're going to double that mass. So 55.8 times 2 gives you 111.6, and so on. So if I have 81, if I have 81 grams per mole of aluminum, how many moles is that? That's going to be 3 moles. Okay? 3 times 27 gives you 81. All right, so here's just a little bit of a discussion of what a mole actually is. So let's start to getting into some conversions. And we're going to use dimensional analysis just like we always have. All right, and the way you do this is you take your number, 3.80 grams of copper, dot line. All right, if you have grams of copper here, where do you put grams of copper? You put it on the bottom. You're converting to moles, so you always put whatever you're converting to on top. All right, now you have a blank here, and this is where you're going to use the molar mass of copper. The molar mass of copper is 63.5. Now, grams has to cancel out with grams here. The number that goes here is the molar mass, which is let me do it this way, the molar mass from the periodic table. So all I got to do is look at this on the periodic table, and I'll be able to determine what the molar mass is. Now, let me just erase this. You have 3.8 here divided by 63.5. Let me just get that on my calculator. 3.8 divided by 63.5. You end up with 0.0598. 0.0598 moles of copper. Okay? Let's try this next one right here. Or actually, let's try this third one. You have 7.99 moles of sulfur. All right? If you have moles of sulfur here, where does it go? Hopefully you answered on the bottom. And I'm converting to mass. So whatever I'm converting to typically goes on top. The question is how much mass? Or where would you find this number? What number is always associated with grams of sulfur? And that answer is the molar mass. Molar mass is the same as the mass number on the periodic table, and for sulfur it's 32.1. Cancel, then in this case you're going to multiply 7.99 times 32.1 gives you an answer of 256 grams of sulfur. Okay, let's try some more. All right, now I'm going to go moles to number of atoms. All right, let's try this first one. I have 2.5 moles of carbon, and I want to convert this to number of atoms. So moles of moles of carbon here gives me moles of carbon on the bottom. How many moles? 1. It's always 1 mole until we get to later chapters, okay? And something called stoichiometry. But for now, it's just 1 mole. Next, you're going to go to convert to number of atoms. So put atoms of carbon on top. Now, what number is always associated with atoms, molecules, or ions? And again, hopefully you're thinking 6.02 times 10 to the 23rd. So moles of carbon cancel, and in this case I'm going to multiply, and I take on my calculator 2.5 times 6.02, hit the EE button, go to 23, hit equals, you have 1.51 times 10 to the 24th. Okay? So that's converting from moles to number of atoms. All right, next, let's go down to this third one here. We're going to convert 4.81 times 10 to the 24th atoms of silver to moles. All right, so in order to do this one, you take your 4.81 times 10 to the 24th atoms of silver, dot line. Now you have atoms of silver here, so you better put atoms of silver on the bottom. What number it goes with atoms? 6.02 times 10 to the 23rd. Now I got to go to moles. So that goes on top. 1 mole of silver on top. You get your atoms to cancel out. In this case, you're going to divide. So 4.81 times 10 to the 24th divided by 6.02 times 10 to the 23rd. And I get 7.99 times 7.99. That's the answer. Moles of silver. Okay? Next. Let's get a little bit more difficult. Now I'm going to have a molecule or a formula unit. We'll just call them molecules to make it simple. We have 63.2 grams of C2H2, which is something called acetylene. And we have grams here. Grams cancels out on the bottom. But now I don't have just a raw atom, I have a molecule. So what I need to do is take the molar mass of 2 carbons and add that to the molar mass of 2 hydrogens. So each carbon is 12, and I have 2 of them, and each hydrogen is 1, and I have 2 of those. So 12 plus 12 is 24, plus 1 plus 1 is 26 grams per mole. So I'm going to use this as my molar mass for CH2. So 26 grams, and I'm converting to moles of C2H2. And by the time I hit equals, I'll have 63.2 divided by 26.0. I should probably get 3 sig figs. 63.2 divided by 26.0 gives me 2.43. So all you're doing extra in this step is adding up the molar mass of the full molecule. Let's do another one. Let's do this second one right here. All right, so we're going to go 412 moles of HNO3. And I want to convert that to mass. So moles is here, so moles go on the bottom, and it's always 1 mole for now. And we want to go to mass, so that's grams of HNO3 on top. Well, now I have to add the mass of, and let's just do this out loud here, HNO3. The molar mass of hydrogen is 1. The molar mass of nitrogen is 14. And the molar mass of 3 oxygens, that's 16 times 3 is 48. So I'm going to add those together. That's 48, 58, 62, 63 grams per mole. All right, so 63 grams per mole, and I'm going to multiply 412 times 63. That's going to be a bigger number. Is 2.59 or 2.60 times 10 to the fourth grams of HNO3. Okay? All right, let's move on. Let's try some harder ones. I think this is as hard as I can get. All right, this is as I shouldn't say that. This is as hard as they get. So here we have 5.12 grams of potassium, and I have to go to number of atoms. Now let me do something first. Let me just tell you, if you have A is equal to B and B is equal to C, they're both equal to B. So therefore, A and C must be equal. Okay? So A and C must be equal. So if that's the case, if I have 1 mole is equal to molar mass, and 1 mole is also equal to 6.02 times 10 to the 23rd atoms, molecules, or ions, if they're both equal to the same thing, then these two must also be equal. So molar mass is equal to 6.02 times 10 to the 23rd. Atoms, molecules, or ions. So let's use that information and go back to this slide. So if I have grams of K here, I better put grams of K on the bottom. How many? I believe it's 39.1 grams of potassium. Now I'm going to go to number of atoms. So very easily I can just go 6.02 times 10 to the 23rd atoms of potassium because of what we just discussed. So I'm actually skipping a step here by combining the two. All right, so 5.12 times 6.02 times 10 to the 23rd, it equals, oops, I think I screwed up. Let me try that again. 5.12 times 6.02 times 10 to the 23rd, there we go, times 10 to the 23rd, it equals, divide by 39.1, gives you 7.88 times 10 to the 22nd. Okay, let's try every one on this page. I think that's going to be helpful. So if we go 4.00 times 10 to the 23rd atoms of oxygen. So now I got atoms here, so atoms go on the bottom. What number is always associated with atoms, molecules, or ions? And that answer is 6.02 times 10 to the 23rd. And I'm going to mass, so I better put grams of O on top, and that is 16.0. So you take 4.00 times 10 to the 23rd times 16 divided by 6.02 times 10 to the 23rd, and you end up with 10.6. Our answer is 10.6 grams of O. Okay? Now, these last two, this is the hardest I can possibly get. Here and here are the hardest I can get. So let's give these a shot. All right, let me switch colors here. 0.75 grams of H2O. Dot line. Now I got grams here, so I better put grams here. How many grams? Well, instead of having just a single atom, I got to add up a molecule. So I have 2 grams per mole contained in the hydrogens. That's 1 plus 1 plus 16 is 18 grams per mole. Now, since they're both equal to moles, I can go right to the number of molecules by putting this on top. 6.02 times 10 to the 23rd molecules, and you can't abbreviate it, of H2O. So 0.75 times 6.02 times 10 to the 23rd divided by 18 gives us 2.51 times 10 to the 22. molecules of water. Okay? There's that one. And then this last one, again, it's the same thing except reversed. Same concept. We have 9.71 times 10 to the 25th molecules of NH3. And we have molecules of NH3 here, so we better write molecules of NH3 here. And what number goes with atoms, molecules, or ions? And hopefully you're saying 6.02 times 10 to the 23rd. And of course I'm going to mass, so mass goes on top. Grams of NH3 on top, and that is 17.0. So those cancel out, so 9.71 times, times 10 to the 25th, multiply that by 17, hit equals, divide by 6.02 times 10 to the 23rd, hit equals, you end up with 2,742. So 2,742 is times 10 to the second, just giving us 3 sig figs grams of NH3. Okay? Ladies and gentlemen, that's it. That's as hard as I can get it. So if you need help, tweet me or go to my website, which you're probably on since you got this video, or email me. Okay? Good luck and see me for any questions.